Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel, your place where you can learn about math and science. Today we are in physics. We're working on chapter 11, which is energy, and I'm going to show you how to do some of the math problems that have to do with kinetic energy, potential energy, work, collisions, things that have to do with energy. So you don't have to be taking this class to learn how to do these problems. So welcome whether you're part of the class or not. Please like, share, and subscribe. I really need the subscriptions to make my life easier as far as making these videos for the homeschoolers go. All right, so in our book, we're in chapter 11. And our first problem is on page 221. And remember, I always say about the problems of physics are word problems. And what we want to do is get rid of the words. Okay, so we read along till we get a number. A shot putter heaves a 7.26 kilogram shot. That's a mass. So first we write mass equals 7.26 kilograms. Write it down with the units. With a final velocity of 7.5 meters per second. So I put velocity final equals 7.5 meters per second. And I guess, as I'm sitting here thinking, I bet we might need the initial velocity too. And of course, it would have started off at 0, so I wrote that down too. Okay. A says, what is the kinetic energy of the shot? So what I don't know is kinetic energy. So step 1, list your knowns and unknowns. And see how much nicer that is than all those words. So much nicer to see the numbers. So now I ask myself, is there a formula for kinetic energy that uses mass and velocity? Ding, ding, ding. Yes, there is. The kinetic energy equals 1/2 mass times velocity squared. And this would be our final kinetic energy because our initial kinetic energy would have been 0 because you would put a 0 there. Okay, so kinetic energy equals 1/2 times the mass times the velocity squared. Just in case you don't know how to do that on your calculator, let me clear out all that stuff. It's more fun with sound effects. Now, just for ease, I use 0.5 for a half, and then I can use parentheses or times 7.26 in parentheses, and then 7.5. And always use this button for your squared. For the other exponents, you can use the up, but for squared, use squared. The reason why is because I teach math and science, a bunch of it, and where kids get things wrong, I see because I grade their papers, and they'll be up here in what I call exponent land, and they'll forget to come back down to numerator land, and then below that you have denominator land, and they'll get it wrong because of that. So usually if you use an exponent, it's squared, and so if you usually use that button, you won't ever have that problem, because see how the little blinky light is back down here again. All right, so we say enter, and there's the answer, 204, and it rounds off, and the unit is joules. Okay, so for B, it says, the shot was initially at rest. How much work was done on it to give it this kinetic energy? Well, is there a formula? Yes. Work is the change in kinetic energy. And the initial kinetic energy was 0, because anything 0 squared is 0. Anything times 0 is 0. And so my change in work was final minus initial, 204 joules minus 0 joules is 204 joules. So that was easy. That one wasn't bad, was it? Okay, let's do another one. Move this stuff out of the way. Sorry about that. Okay, there's somebody juggling. My brother-in-law used to know how to do that. I always thought that looked fun, but I've never done it. Never mind. Okay. All right, so the next one is example problem with gravitational potential energy. So our formula for that is potential energy equals mass times gravity times height. Okay, so we have a 200 kilogram textbook. So step 1, list your knowns and unknowns. Not 200, it was 2.00. A 2 kilogram textbook is lifted from the floor to a shelf 2.1 meters above the floor. So my distance is 2.1 meters. That's the height. And then it says, what is the potential energy? Well, there's my formula. And so now I just substitute in for mass 2, gravity 9.8, and height 2.1. Multiply them on my calculator, it's 41.2 joules. That was A. B says, what is its gravitational potential energy relative to the head of a 1.65 tall person? So how much more energy does it have if you put it all the way up to your head? So my second distance is 1.65. So my height difference is 210 minus, 2.10 minus 1.65 is 0.45. So 0.45 meters is the difference. I put that in for my new distance. So the weight is the same, gravity is the same, and that's my new distance. And the answer, is 8.8 joules. All right, that one was easy. Moving right along. Footloose and fancy free, like the Muppets say. Okay, problem number 3. A large chunk of ice with a mass of 15 kilograms. So I don't know what this problem is yet, but I'll list any number I write down as I come to it. Falls from the roof 8 meters above the ground. So I have a distance of 8 meters. Find the kinetic energy of the ice when it reaches the ground. Okay, so what is kinetic energy? And there is a relationship. The kinetic energy when it reaches the ground is going to be 0. When it's falling, it's got some kinetic energy. The potential energy at the end will also be 0. But we're going to look at the kinetic and potential energy before and after. So the first kinetic energy and potential energy, and the second kinetic and potential energy. At the beginning, the kinetic energy is 0. Potential energy is mass times gravity times height. At the end, the kinetic energy is mass times gravity times height, and the potential energy is 0. And these are the same. So all of that is to say we're allowed to do this formula saying kinetic energy is mass times gravity times height, because the energy gained by one is lost by the other. Okay, so my kinetic energy final is the mass 15 times the gravity 9.8 times the height, which is 1180 joules. On your calculator, it'll be 1176. The book rounds it. Always know the book rounds. The second thing they ask is, well, what is the speed? So the kinetic energy, the formula that's got speed in it is kinetic energy is 1/2 mass times velocity squared, or speed. So the kinetic energy we already got is 1180. And then 1/2 is 1/2, the mass is 15, and the speed is what we don't know. So we do 1180 divided by 1/2 and 15, and to divide by a fraction is the same thing as to flip it and multiply. That's what we do in the math classes. Okay, so and that would be velocity squared. We only want velocity, so we take the square root of the whole thing, and square root is the second of the squared button. And it's 12.5 meters per second is the velocity. All right, that one wasn't too bad. Oh, and the last one was, is the answer the same as you would determine by solving as a constant acceleration problem? And the answer is yes. Okay, number 4. It says, a block A with a mass of 12 kilograms, so I wrote that down first, is moving at 2.4 meters per second. So I wrote that down for a velocity. Makes a perfectly elastic head-on collision with a block B, mass 36. So I wrote that down. At rest, find the velocities of the 2 blocks after the collision. So this would be like the primes are after, so the velocity A and velocity B after the collision is what we're trying to get here. Okay, so we have 2 formulas. And the math here is a little complicated, the way they derive the formula, but if you just know to use the formula, it's not so hard. So where they got the 2 formulas is the energy formula that shows that the energy is conserved, that what you start with is what you end with, that they're equal. And that's where you do the 1/2 mass times velocity squareds for each one. And then the momentum is also conserved, the mass times the velocities of each one. Okay, so what they did is they showed that they got these formulas. They substituted one formula into the other. They got it as a quadratic equation, and then they solved the quadratic equation. So like I said, this is some pretty fancy math. But they got these equations here, that your velocity primes, your velocities at the end, are equal to the difference in the masses and then plus the masses. And the velocity prime here is 2 mass times velocity over adding up the masses. So we can solve those. So what you do for A is you subtract your 2 masses to find the change in mass, the differences in the mass of them, and then multiplied by the velocity of A, because we're doing A is 2.4, divided by adding the masses, okay? And that equals negative 1.2, and that means it bounced back. For B, we use this equation, and is 2 times the mass times the velocity, 2 times 12 times 2.4, divided by the masses added together, and it is equal to 1.2 meters per second forward. So that one bounced back, that one bounced forward with a velocity of 1.2 meters per second. All right, so just see if you can put it in your calculator and get it. Okay, here's number 5. An accident due to slippery roads, a compact car with a mass of 575 kilograms, so I wrote that down, is moving at 15 meters per second, so I wrote that down. Smashes head into the rear end of a car with a mass of 1575 kilograms, originally moving at 5 meters per second. They lock together. So this is not elastic. They're not bouncing off. They're stuck together and slide forward. This is like the train cars from last chapter. A, what's the final velocity of the wrecked car? So what's final velocity? Well, we have a formula that they give us, that you add up the mass times velocities divided by the masses added together. So that's 575 times 15 plus 1575 times 5 over 575 plus 1575, and that's 7.7 meters per second. Okay, B, that one wasn't too bad. How much kinetic energy was lost in the collision? Well, the change in kinetic energy is equal to the final kinetic energy minus the initial kinetic energy, which is the final kinetic energy is 1/2, add up the masses, V squared, minus, and our initial kinetic energies, we have to do it for both and take them both out of there. So it's 1/2 mva squared minus 1/2 mvb squared. So you can put all of this just straight in your calculator, substituting in the numbers. 1/2 575 plus 1575 times 7.7 squared minus 1/2 times 575 times 15 squared minus 1/2 times 575 times 5 squared, and it comes out to be that, which your book rounds off to that. Okay, so that was B. C says, what fraction is lost? And they tell us that we should do the change in kinetic energy divided by the initial kinetic energy. Well, we know the change in kinetic energy is what we just solved for, but we need to know what the initial kinetic energy is, and it's these two kinetic energies added together. So we're going to do 1/2 575 15 squared plus 1/2 1575 5 squared, and that's 84,375. Okay, so I'd have my initial kinetic my change in kinetic energy divided by my initial kinetic energy, and it's negative 0.25 if you round it off, which is negative 1/4, which means 25% was lost. Sorry I wrote so messy on that. Usually I just write those out for myself to teach. I'm not usually showing people my book. But I write messy anyway. It's just the way it is. All right, next time will be thermal energy. I like that. And look, we have some sort of interesting thing there. All right, so come back, like, subscribe, and share it with all your friends. And I'll see you next time. Math is great, science is great, physics is great.